You are given two coherent sources of intensity ratio alpha. Of intensity ratio alpha. That means if I'm having two sources I1 and I2, I1 by I2 will be alpha. You have to prove that visibility is given by we just now saw the expression I max minus I minimum divided by I max plus I minimum is equal to 2 times root of alpha divided by 1 plus alpha. Prove it. Understood the question? So you are given the intensity ratio. So if you take the amplitude of one of the sources as A1 and other sources as A2, then A1 by A2 whole square is this alpha. So now what you are given is the ratio of intensities. So let us again define Imax as A1 plus A2 whole square and I minimum as A1 minus A2 whole square, and we are also given that A1 by A2 whole square is actually alpha. So just substitute. So your Imax would be equal to, or better to write Imax minus I minimum. That is, our numerator will be equal to, if I subtract this from here, I will get 4 times A1 A2, and the denominator I max plus I minimum will be equal to 2 times A1 square plus A2 square. So if we substitute these two quantities, we will get visibility equal to 4 times A1 A2 divided by 2 times A1 square plus A2 square. Just solve it. This will go away. So we will have 22. So we will have 2 times A1 A2 in the denominator. If I take 1 A2 square common, I will have 1 plus A1 by A2 whole square, because you remember we want to substitute that alpha over here. So this will give you 2 times, if this A2, one of it will get cancelled, and then we will be left with 2 times A1 by A2 divided by 1 plus A1 by A2 whole square, which we can rewrite as V equal to twice of A1 by A2 is root of alpha divided by 1 plus A1 by A2 whole square is alpha. Okay.